Hi, and welcome to this course on how to migrate from Windows Identity Foundation to OWIN middleware, where we will demonstrate the necessary steps in order to go from using WIF components to the newer OWIN security middleware for federated security. We will start by building an MVC solution from scratch, then add the WIF components to it, such as the WS Federation Authentication module, or FAM, and the session authentication module known as the SAM. Then we will wire up the authorization manager and an authentication manager. Lastly, we will configure a trust relationship with an external STS. We will then proceed by migrating the solution by replacing the WIF components with their OWIN counterparts. The WS Federation Authentication module will be replaced by the WS Federation Authentication middleware, and the Session Authentication module will be replaced by the Session Authentication middleware. Lastly, we will refactor the authorization and authentication managers to authorization and authentication services respectively. Now we will not change the protocol used between the app and the STS, which is WS Federation, nor will it remove the use of cookie. It will merely help you to migrate from Windows Identity Foundation and to give you a good starting point using OWIN security middleware instead. As for the decision to build the project from scratch, although it would be easier just to use the pre-made project scripts and to configure the trust using the security wizard, in my opinion, this adds a lot of unnecessary code to the project, and it also hides a lot of the details that we really should be aware of. And in any case, building your project from scratch like this is good practice for understanding just how the security of the solution is built up, and also to ensure that you only add components that are absolutely necessary to your project. For the demo, we will use an external security token service, and the STS of my choice is the open source project Identity Server 3, which I have pre-configured ahead of time. As you probably already know, the choice of STS is really up to you and the requirements of your particular project. And now we will be using the WS Federation protocol the entire way, so that any STS that supports this protocol will do nicely. So we will start by going File, New Project, and choose Web. We will call it WIF to OWIN demo. That will do. And then choose the empty template for our project. Now we could use the starting template that comes with Visual Studio, but as I said before, I think these templates add a little bit too much code that's not really necessary. So we will start with the empty template. So now that the empty template is done, we can proceed with installing the NuGet package for ASP.NET MVC, which will add all of the references that we need. Now we will be using the Razor view engine. So in order for that to work, we need to add some configuration. Now I've got a code snippet here that will do that, so I'll add that in now. This will get the Razor views working. And now we can add our first controller. So by convention, that will go into a controllers folder. Add new class, and we will add a home controller. Now this will be the only controller that we will actually need for this entire demo. Now, very important, make it public, otherwise it will not work. And we will add an action method called index, which will return the default view for that action method. Now we don't have that view yet, so we will have to add it. And by convention, the views go in the views folder. And as this is for the home controller, we will have to add it to the home folder. And we can proceed by adding the view. And I'll just choose this razor view here. This will be index to match the index method, like so. We don't actually need this markup. We'll just say, welcome, you reached the home view, like so. Now, in order for this to work at all, we need to configure up some default routing. So that usually goes into the app start folder, and we will add a class in here, call it route config. And instead of you watching me type all this code out and getting it wrong, I'm going to use a code snippet for this. This code snippet then sets up the default route for this MVC project, which goes to the home controller and the index view. Now, having done that, let's wire up the routes. And by doing that, we need to add a global SX file, call it global, and our static route config, register routes, and the routes table. Dot routes as input. And there you have it, a bare bones MVC project. Now if we run this, this should be the absolute minimum. Obviously we need this class to inherit the right class from the MVC project modules. So we do like so. Now we should be good to go. And there you have it. We reached the home view. So now that we have our bare bones MVC project as our starting point, we can now proceed to add the Windows Identity Foundation components to it. Now, to protect our solution from unauthorized requests, we need to add this authorize attribute. Now we could add this authorize attribute as a global filter to our MVC project, but for the purposes of this demo, we'll just add it directly to the home controller, which incidentally is the only controller that we're going to use for the entire project. So now that we've added the attribute, we can see that as soon as we fire up the project again, we will get a 401 unauthorized, as our request has not been authenticated yet. Now the next thing that we want to do is to add the federation authentication module and the session authentication module into the request pipeline of the host. And in order to do that, we need to add this system web server configuration, where we remove the default forms authentication module and then add the FAM and the SAM module. And in order for this to work, we will have to reference the correct DLL system identity model services. Now, the next thing we want to do is to configure the system identity model. Now, this configuration, which I will show you here, has registered the issue name registry, which checks the returning security token has been issued by a trusted STS. In this case, we will be using the Identity Server 3 and its default settings. Now that we've done that, we need to configure the trust relationship with the STS. And we do that by adding the system identity model services configuration. Now, as you can see here, we've turned the require SSL to false for the cookie. This is not something that you obviously would do in a production environment, but for the purposes of this demo, it will just it'll do nicely. Now, turning our attention back to system identity model, you will see that I've left the claims authentication manager empty and the claims authorization manager empty. So these are classes that we need to implement ourselves. So we'll do that by adding, now this is infrastructure, so I like to make that explicit by adding these things into an infrastructure folder, and it's security related, so we'll put a subfolder here called security. Now in here we can then add our authentication manager, and our authorization manager. Now the authentication manager, I'll just make this public, will inherit from claims authentication manager. Now this class is baked into .NET, and we will need to reference system identity model for where this class lives. And for our authorization manager, I'll make that public as well. This will inherit claims authorization manager. Okay, and then we will just override the check access method. And for our solution, we will just return true. So everything will be authorized. And for the authentication manager, we will override the authenticate method and just return the incoming principal. So now that we have these authentication manager and the authorization manager classes implemented, we can wire them up into our web config. So we'll go back into there and let's see, start with the authentication manager. I'll just copy the namespace and go to the authentication manager, paste that in, and we need the authentication manager. And also we will need the version number and the culture in order for this to work. So put in like this, and for the same for the authorization manager. Authorization manager. Now, in order for authorization to work, we need to add something onto our controllers to trigger the authorization manager. And for that, we will use the claims principal permission attribute, this one here. And we will say that the security action is demand, and that the resource is home, as in the home controller, and the operation, is the index method, like so. So in order to hit this endpoint, you need to be authenticated and authorized. So we'll make sure by putting some breakpoints in the authentication manager and in the authorization manager to show that this code is actually being run. And we will see what we get. Now, before we can actually run this, we need to configure the STS. So I need to tell my STS what the trust relationship is between the app and the STS. In order to do that, I will need the URL in which my app is hosted on, which I will find here. I'll copy that. And I'll put that into the configuration here. Now you will see that I've already put in the realm and put in the claims that will be returned. So I'll start the STS. And now that our STS is running, we can try to run our app. And it doesn't work. And the reason for it not working was that I had put in the wrong string into the claims authentication manager and the claims authorization manager. I had forgotten to add the name of the project. So now when we run, we will see, hopefully, that we are presented with the login screen of our STS. And the way that this STS is configured, there is two default users, one called Alice and one called Bob. And these are spelled with lowercase letters. So now we see that our authentication manager is being hit, and also our authorization manager. And we're authorized, and we have reached the home view. Actually, to make that very clear, we could go into the view and say welcome user identity name. You've reached the home view, which will only show for authenticated users. Like so. Now that's all good and true, but let's pretend that we actually want to log out of this system as well. So by in order to do that, we will have to add some kind of logout functionality, and we'll just add that directly to our home controller. This will be using the WS Federation authentication module directly, like so, to get a hold of the federated sign out. Now this needs a sign out URL as well as the reply URL. So, and a reply URL. Now the sign out URL will be the issuer that is registered in our WS Federation authentication module. So federated authentication WS Federation authentication module dot issuer, like so, and the reply URL will be the home action. So new URI we'll use this helper method here to get us to the index on the home controller. Route values none, and the protocol will be the same as the incoming request. Like so. Now that we've done that, we should be able to log out as well as log in. So since we're already authenticated, we came straight in, and then we should have on our home controller, we should have a log out action method that logs us out, like so. And now that we've added the Windows Identity Foundation components and established a trust relationship with our STS and ensure that we can log out, we are in a good position to be able to migrate to the OWIN authentication and security middleware. So now that we've done the job of adding all of these WIF components to our project, now comes the task of removing them so that we can replace them with OWIN middleware. So the first thing we will do, we would go into an existing project like this, and we would remove the identity model configuration. You might want to save it to a text file or something in case you need the information inside them at some other stage. We would remove the identity model services, and we then don't need the section names in here either. We would remove the modules from the request pipeline. So now you could probably just remove this whole web server tag here, but I just want to be very explicit to show that these modules are no longer loaded into the request pipeline by doing it like this. So if these modules were for any reason added to the request pipeline, we are removing them. So now that we've done that, we can remove the references, system identity model, do not need that anymore, and the system identity model services. Now once you've done that, if you remember the claims permissions attribute on our controller, that lives in one of those removed references. So we will have to go into our controller, and we'll just comment that out for now. We can also see that this logout code doesn't work anymore either, because we removed the references to system identity model. Okay, now that we've removed all the Windows Identity Foundation components, we are ready to add the OWIN middleware. Oh, and one last thing before we go, we need to clean up our authentication manager. This claims authentication manager is no longer relevant, so we removed the inheritance here. There's nothing to override. We will be using these authentication and authorization managers later. We will refactor them into services, and for that purpose I will no longer need the resource name on this method, and this method will no longer take in an authorization context, but just two strings, the resource and the operation. And I'll remove the claims authorization manager inheriting, and no longer do we override anything. Okay, now we should have a nice clean build in theory. We will fix up these unused directives, and we have a succeeding build. Now, in order for us to add the OWIN authentication middleware to our project, we need to add some packages. We'll start by adding the OWIN host for system web. Then when that's done, we will include the OWIN packages for WS Federation and for cookies. Like so. Yes. And then the last one is the cookies. Like so. So now that the NuGet packages for the OWIN authentication middleware that we need are installed, we can proceed with bootstrapping the middleware. So in order to do that, we will need to add an OWIN startup class. Oops. And I will call it OWIN startup, like so. And we are going to wire up the cookie middleware and the WS Federation middleware, and it's very important that the middleware are configured in the right order. So the cookie authentication has to be done first. This takes in the cookie authentication options, and we will need to name this the instance of this this middleware. So for the cookie authentication middleware, that's the authentication type, and we will use this the static in this class authentication type as the name. Now that we've done that, we can add the WS Federation authentication middleware. Oops. Options, like so. And for this middleware, we need to tell it which other middleware is going to be used to maintain the authentication session. So we need to tell it the sign in as authentication type. And we will use the same name as our cookie middleware, because that is the one that we want it to use. Now there are two other things that we need to add to this. We need to tell it where to get the WS Federation metadata, and we do that in the metadata address. And we need to configure the realm that our app is using. That's WT realm. And in our case, we are using the URN OWIN, WIF to OWIN. And the metadata address is this one here in this particular case for our particular STS, so that you can see that by putting that URL directly into our browser. You will see that I haven't started the STS yet. So we'll just do that quickly. Okay, now we start it again. And we'll try again. And there it is, the WS Federation metadata from our STS. So now by adding this piece of code, we should in theory be able to fire up our app and get redirected to our STS. And there it is. I'll use Alice with lowercase a and log in, and we're logged in again, now using the OWIN middleware as opposed to the Windows Identity Foundation components. Now obviously this will give access to anyone that has a valid account on our STS, as well as give all permissions to any user. So in a real life application, we probably don't want to do that. So in order to help us only allow the true users that we want to allow into our system, we would use the authentication and authorization managers. Now, authentication manager and authorization manager are very WIF specific. So just to make it perfectly clear that these are no longer part of the WIF usage, I want to actually call them services. And it's just to denote that these are application specific classes, just like any other service that you may have in your system. And the way that we would wire up our authentication service is by going into the OWIN startup And in the cookie authentication middleware, we need to add a provider. And this provider of type cookie authentication provider has a on-response sign-in, which is fired when the user is initially signing into our application after they have been authenticated by the STS. This delegate takes in a context, and this context has the incoming identity that was issued by the STS. Which is on the context.identity, like so. Now this is the identity that you want to use for your claims transformation, as well as doing some further checks in your application to see that this incoming identity is actually allowed to use the system. So this is where you would have some very application specific or authentication code. For our case, we will delegate this authentication to our authentication service. This authentication service would probably be injected if you're using some kind of IOC container. I do not have one at the moment, so I will just new it up like so. And then we will use our authentication service. Oops, wrong using. This is the danger of being a little bit too quick. And I've called it authentication services plural. That wasn't very good. And now I can get my authentication service like so. And we can pass it into the authenticate method. Now this takes an incoming principal, and I have an incoming identity, so I will just wrap it like so. Just to make the method happy. And then this service would return us the new principal that has all the correct claims and is authorized to use our system. And then we would set the identity of that new principal onto the context. The identity as claims identity, like so. So that takes care of the authentication on our application side. And now we would like to also make use of the authorization service. And for that we will use an attribute. Now, as if you remember, we used the claims principal permission attribute on our controller, but this claims principal permission is no longer available as we are have removed Windows Identity Foundation. So what we will have to do is create our own attribute. At this stage, I would like to say that there are a number of good open source projects think texture identity model being one of them that have pre-implemented some of these attributes. But for the purposes of this demo, we will just write our own custom attribute. And that custom attribute, or just call it custom to make it perfectly clear. Authorize, like so. And to save some time, I'll just add the definition here so you can see it. That will inherit from attribute from MVC. And it will take in a resource. Oops. Probably don't need to format it like that. Just to save some space. And an operation, like so. And we will need to override on authorization method. And again, I'm going to new up our authorization service. Manually, like so, but obviously you would probably inject that using an IOC container. And our authorization service has a check access, which takes in the resource and the operation, like so. Now that that is done, we can proceed with adding the resource and the operation that is required for our custom authorized attribute, like so. I'll just remove the old claims principal permission as we don't need it anymore, like so. Okay, good. So we should have a nice clean build. Good. I'll just put this custom attribute in its own file. Actually, first of all, I will move it out of the controller class, like so. And now I can add it to its own file. And this is also infrastructure, security infrastructure, so I'll put it in here, like so. Good. So now we can run the code, and let's just add breakpoints into our authenticate method and our check access method to make sure that these services are actually being called. So we were already authenticated, we haven't logged out because we don't have the logout functionality implemented yet. We'll get to that shortly. So our authenticate method on our authentication service is being hit, and our check access is being hit. Now obviously this you would have your own application specific check access code in here. And we're back into the view. So the only thing remaining now is to add the logout functionality. Now, since we removed the logout code from our controller, because this was Windows Identity Foundation specific, we don't have a logout for our app. So what we will need to do is to add OWIN specific federated logout. And to do that, we need to get the OWIN context, which we get from the request, like so, and the authentication, and we can sign out. And now we need to tell the authentication sign out method which middleware will be responsible for performing the sign out. So if we go into our OWIN setup, it is the WS Federation middleware that will be used for the sign out. So we will copy this name. Actually, we will not. I will need to give it a name. So authentication type, and that is the WS Federation authentication defaults authentication type. And now I will copy this and say that this middleware is the one that's being used for the sign out. Good. I think we'll remove this old zombie code like so. And now when we fire up the app, we are probably still logged in. So authenticate, check access, and we're in. And now we should be able to go to home controller where there's a logout endpoint, like so, and we are logged out, aren't we? Well, in this particular case, I don't actually think we are, because if I go back to our app, oops, I'm still authenticated and I can still go into the app. So what's actually happening here is that the SDS is not redirecting us back to our app in order to do the cleanup. So the session cookie that was given to us is never cleaned up on our side. Now the session is terminated on the SDS side, but if we go into the resources, this cookie here, which tells us that we are authenticated, is not cleaned up. And in order for that to work, we need to go into and using SSL. Now the reason for that is if we look into our favorite proxy tool, Fiddler, we can quite easily see side by side, that when we sign in, like so, and get Fiddler up again, and then we try to log out, is that we are never actually redirected back to our application. See, all the calls here are to 44333, which is the SDS. So the sign out cleanup signal is never sent back for us to clean up our login session. Now to fix that, I will need to host this application in SSL, which we do in these properties down here, and where we enable SSL. Now this will be a new hosting URL, so we will need to give the STS the new URL that we are going to be hosting on. So just before I do that, go into here and change it here, and I will change it here in our STS. Like so. Good. And that's running, and that's running. And now we should be good to go. So if we fire up our application again now, and we use Fiddler, just clean this out. We log in. Yes, yes. And then use the home logout and log out again. We will see when we go back to Fiddler that the sign out cleanup signal is sent back to our app from the STS. So now surely we will be logged out. Well, not quite. Turns out that there's a little fix that is necessary. Dominic Bayer has kindly alerted us to it, so that there is a fix available. So as we saw, although we were redirected back to our app from the STS with the cleanup signal, the cookie was not cleaned up, so we were not actually logged out. Now, Dominic Bayer has kindly given us a solution for this, which we are going to use now in order to fix this problem. So the fix is published on Dominic's blog here, and this is the fix that we will actually use for making sure that the logout is performed. So we will need to add that into our own startup as some middleware like this, and I'll just paste the code directly in from his blog like so. So basically it comes in and checks that there is a WA query on our request string, and if that is equal to WSignout cleanup 1.0, then we will go ahead and pull the cookies off the browser. So now that when this is done, we can see, just get Fiddler going again. When we log in, yes, maybe I should remove these breakpoints, they aren't really necessary anymore. That when we hit the logout endpoint, and we say yes, yes, the signal has come back and we should be logged out, which means if I go back to our app, we're not logged in because the session was cleaned up. So after building up and tearing down a perfectly good Windows Identity Foundation based MVC project and adding OWIN security middleware, we now have a functioning app using WS Federation and OWIN. Now, there are a lot of things that need to be done in order for this to be a production-ready product. One issue is cross-site request forgery problem due to the use of the cookie to hold the session information. And obviously, we would need to flesh out the authentication and authorization services with application-specific authentication and authorization logic. But this is a good starting point. I hope you have enjoyed this demo as much as I have enjoyed making it, and until next time, cheers.